a little bit. We're not sure how much, maybe less than a meter. But on the southwest coast of Florida, in a cross-section, some work by Sarah Gelsenmeyer, one of my students, we could see this is a freshwater organic beach as sea level was rising, and then as in this cross-section along that yellow line, you can see the red mangroves moving seaward several kilometers during this time of gradually lowering sea level. And then about 2,500 years ago, we had a quick rise, probably only a meter. Doesn't sound like much, does it? And all hell broke loose on the coastline. And over the next, you have a quick rise of sea level. All the coastal bays and mud banks and all these beaches and everything's destabilized. New wave and current regime. And for the next 400 years, huge volumes of mud and organic matter on this coast were moving around, finding a new place to go. And what they did was build a huge mud flat along this coast and along the north shore of Florida Bay. The orange is the part that you would have had a picnic on. The other you would have mucked through. And so on top of this lowering sea level, suddenly this huge amount of material was piled up. And then, since that time, as sea level has more gradually risen to its present level, this area is sort of filled in. These are sort of the framework for the this vast, magnificent wetland coastal complex we have on the southwest coast of Florida. And so, all the way through, whether you were looking earlier, where Locker and all, or Anderson and all were looking, they see the same thing, jump, 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 pause. Not just a gradual linear response to changing conditions, okay? And that's the important point from looking at our past, is when climate is changing, there tend to be tipping points in the climate that lead to rapid melting of ice, and that leads to rapid changes in sea level. And the problem is that all our models looking to the future that scientists are using, the models, only an input of carbon dioxide, greenhouse gases, a linear response of climate, ice melt, and sea level. They cannot recognize these tipping points, the sudden destabilization phases of rapid ice melt and resulting rapid steps of sea level rise. But that is how it works. So understand models have severe limitations. Global warming is well underway. And it's already changing our environment. And it will be changing, certainly in the young folks' lifetime. It will be changing Earth far beyond your wildest imaginations. To John Van Leer and my fascination, I won't say delight, it's already changing things that we didn't think we would see in our lifetime. Of course, global warming happens because of carbon dioxide, methane, nitrous oxide, and other greenhouse gases that absorb back radiation of the sunlight from the Earth and turn it into heat, are building up because of human activity. This is a record from Mauna Loa that's began in '57, and in spite of the fact that you bought a Prius, planted some trees last year, CO2 is still increasing, and it's increasing at an increasing rate. Of course, we have still a population explosion underway globally, and we have industrialization of new countries like China and India underway, and this is all a problem. So we're not getting hold of this problem globally, and I don't think we're really getting hold of it locally. Sea level rise, well, sea level is responding to this warming. In fact, you can see a noticeable increase in the rate of sea level rise beginning just about with the Industrial Revolution, when we started pouring carbon dioxide through coal-fired energy into the atmosphere. But this is the global sea level curve as presented in the 2007 Intergovernmental Panel on Climate Change report. This is UN's science body that advises on science. This is their most recent report. And they've used tide gauge and other information to try to reconstruct historical sea level globally, not just locally. And what you see here is a very noticeable hint about 1930, with an increase in the rate of rise. And also note the black area right here. That's the last decade where we've been monitoring global sea level by using satellites, repetitive runs measuring the elevation of the surface of the ocean. We're presently rising at about 30 centimeters, about a foot per century at that rate. South Florida's curve looks just like this, because we're not especially locally subsiding or uplifting. So this is our sea level curve, basically. And we see the same hinge about 1930. If you live in New York, they have subsidence, regional subsidence, related to the glaciers melting and material from the mantle moving back north. Their relative rise of sea level is about 2 feet per century. You go to Galveston and Mississippi Delta, Shanghai now, they are busy sucking water and oil out from under them. They're sucking themselves underground as the ground collapses, as the waters withdrawn. There, Galveston, much of the Delta is rising at a relative rate of about 3 feet per century. So this is what we're doing now. And it's now well documented that this is because of the warming of the oceans, causing expansion of the oceans, because of the buildup of greenhouse gases. Global warming is when the atmosphere warms because of the greenhouse gases, and then that heat, just like if you turn up the temperature in your bathroom and you have a cold tub, gradually heat will be taken out of the atmosphere to warm the ocean. And it will be a long time to equilibrate with your atmosphere. And so we're busy warming our ocean gradually. This rise of sea level has done an amazing job of destabilizing not only our beaches, where many of us live, but also our coastal wetlands throughout South Florida. And I don't have time to go into this today, but everywhere you look, we're seeing a loss of mangroves, sea level rise combined with hurricane setbacks, expansion of saline intrusion into what was freshwater marsh areas, and this is only going to get worse. What's the future? Well, in 2001, the Intergovernmental Panel on Climate Change, UN, the IPCC, put out a forecast for the coming century. And they said the median rise for the coming century would probably be about 2 feet. Maybe, especially if we don't get our act together and get off this fossil fuel burning bandwagon, maybe it would be more. And if we really got our act together and we're lucky, maybe it would be less. That was the forecast in 2001. How have we done since then? Well, here's the projections for sea level rise global based on those low, medium, and high projections for the year up to 2007. And here's the satellite altimetry, sort of smooth. We're running at the high end, not at the median end, okay? In 2007, they came out with a further projection, a new report. It got the Nobel Prize, shared with Al Gore. And by and large, it deserved it. But I was driving back from Newfoundland at the time, and I heard on the radio they had reduced their projections down to only about a little over a foot for the median. And it was like, what? And when I got back here, I found out that what they had done was ignore what was happening recently in Greenland and the Arctic. They added 3 paragraphs to their new lower projection. The projection, people use a graph, they don't read words, but they had 3 paragraphs in there, and these 3 paragraphs said the following. Thermal expansion, forming the ocean, is expected to contribute more than half of the average rise in the coming century, but land ice will increasingly lose mass, adding new water to the ocean as the century progresses. And then they said an important uncertainty relates to whether discharge of ice from these ice sheets will continue to increase as a consequence of accelerated ice flow, as has been observed in recent years. What that paragraph says is that Greenland was starting to come alive and rapidly melt far beyond what the models were projecting, and they didn't have it they only review literature. It wasn't in the public literature, and I bet there was some political pressure to ignore it. So they did, and they hid it in this one paragraph. And the third paragraph says, the models we were using didn't forecast this, we don't know what to do with this, so we ignored it, basically. And so what they produced was actually a very meaningless projection for the coming century. And so really the future of South Florida, because we're so tied to sea level here for our future, depends on what's happening in the Arctic, Greenland, and Antarctica. And since about 2000, Greenland and the Arctic pack ice have been rapidly falling apart. I don't have time to do my full spiel on it, but basically all the measurements on Greenland show a rapid loss of mass that is continuing. And there are feedbacks that aren't expected that are driving this to a new, rapidly increasing rates of loss. And it's increasing to higher elevations to melt and farther north every year. The blue is areas of loss of mass. The next picture is from the orange arrow there area. And what's happening is for like a 100-mile fringe on the edge of the ice sheet, that's a pretty wide fringe, they're starting to get open lakes and rivers on the ice sheet. And these rivers flow along, and just like the rivers in Florida, suddenly disappear down moulins, down sinkholes in the ice. They're dissolved by this warming water. And these go right to the base, lubricate the ice sheet, and so on. But we're seeing a rapid acceleration in the loss from Greenland, and scientists are now realizing all their models were screwed up, and they're trying to figure out how to predict the future, because we don't have an ability to do simple computer modeling of this. In addition, the Arctic Ocean is rapidly losing its summer pack ice. This picture is from 2005. It was a record low year. Then 2007 had less ice cover. 2008 in the summer had more ice cover, but it was thinner. There's less ice volume, and it's now so thin and broken up that it could easily wash out to sea within a few years. And we would have an ice-free Arctic Ocean in the summer. About 10 or 12 years ago, it was projected that maybe the Arctic would be ice-free by 27. Then about 5 or 6 years ago, well, maybe by 2040. With what's happened in 2005, 7, and 8, scientists that work there say the Arctic may well be ice-free in the summer by 2013. When that happens, we are going to have an amazing change in the way things work. It is that Arctic pack ice that keeps the tundra, the frozen ground on the land around the Arctic Ocean, frozen. That tundra has huge volumes of organic matter frozen into it. As that thaws, that organic matter decays and will be putting out ungodly amounts of CO2 and methane, both powerful greenhouse gases. In addition, the north end of Greenland is kept cold by the cold Arctic ice. It's the refrigerant for the Arctic. And we will see, I think we will start, if you're worried and want to know when when global warming has started to run out of control, it's going to be when this is now ice-free. So watch it. And then we're just going to have a snowballing effect, a pulse of new greenhouse gases coming in that we did not directly create. We probably will be starting to get off the bandwagon a little more at the rate we're going. But it's going to be an insult to our efforts, but it's the way it works. And as you start to see, this event today is called about for the next decade, and I said, really, just the next decade? Well, that is what's going to happen in the next decade. And that is going to be a turning point, one of those tipping points that there is no short-term return to. Ice reflects about 100% of the incoming solar radiation. Water absorbs like 90% of it. And in the summer, low incidence of light, but 24 hours of sunlight. There's amazing warming going on in the Atlantic and the Arctic Ocean right now in the summer. And that's going to be out of hand and just snowball us to a new climate state, a new rate of ice melt, and a new sea level condition. Here's the warming that's been occurring after the 2007 The red is anomalously high temperatures because of this absorption.